Hello student, welcome to the one more session of microcontroller and embedded system. I am Vasan Naik from Canara Engineering College. In the last session, we studied the different types of memory which is used inside the embedded system, that is ROM and RAM. Different types of ROM we studied, different types of RAM we studied. Other than that, in the last video we have seen what are the different input device and output device like sensors and actuators. So in this video we will study the working of a stepper motor. Stepper motor is a output device. So stepper motor is a electromechanical device. It will produce discrete rotation based on the input signal, that is electrical signal from the this one processor. Based on the electrical signal from the processor, it will produce the discrete rotation. That means you can control the stepper motor. You can control the stepper motor to rotate in the either direction in the different angle. So stepper motors are widely used in different applications like industrial embedded applications. Then it is also used in robotics control systems, and it is also used in like small stepper motors are used inside the CD drive, DVD drive, etc. That is consumer electronics. Then inside the printer you can find like the stepper motor. The main application of the stepper motor inside the printer to move the cartridge to left and right or right to left. And also stepper motors are used inside the printer and fax machines for the paper feeding mechanism. Like this, there are so many applications of the stepper motor. So based on the coil winding arrangement, two-phase stepper motor is classified into: one is unipolar, second one is bipolar. So unipolar stepper motor contains two windings per phase. Then bipolar stepper motor contains a single winding per phase. So there are two windings here, single windings. So here you can see the diagram, schematic diagram of the stepper motor. You can see here four windings or four coils, or you can call four poles, A, B, C, D. So this is the rotor section which rotates actually. This is the rotor section which rotates, and this is the stator section which is fixed. This is the stator section which is fixed. So now, the direction of rotation of a stepper motor is controlled by changing the direction of the current flow. So here you can see the coils are represented by A, B, C, D. Coil A and C carry the current in the opposite direction for phase 1. Similarly, B and D carry the current in the opposite direction for phase 2. So coil A and C carry the current in one opposite direction for phase 1, and similarly coil B and D carry the current in opposite direction for phase 2. In bipolar, as I said, it contains single winding. So single winding for reversing the motor rotation in the current flow. So like for reversing the motor rotation, the current flow through the winding is reversed dynamically. So before proceeding to there are different types of stepping of the stepper motor. So that is full step, half step, wave step, etc. We will see now the working of the stepper motor, how it works. For the representation purpose, I have drawn the I have used this diagram. Here you can see like four poles are there. That is, there are four poles here. You can see A, B, C, D. A and C are opposite poles. So similarly, B and D are the opposite poles. And on each pole, or on the coil, you can see the winding. And these windings are opposite in direction. You see the windings of this one. The windings go something like this. Here you see the windings go something like this. So windings are opposite in direction. Similarly, you take the pole B and D. Here also the windings are opposite in direction. So this creates like both like south pole and the because of this opposite the direction of the windings, one pole acts like a north pole, other pole acts like a south pole. One pole acts like a north pole and other pole acts like a south pole. So if I want to rotate the rotor, I have to energize the coil A and C. When you energize the coil A and C, then it will rotate one step. That time you have to make the coil, you have to de-energize the coil D and B. That is, suppose if I give logic 1 to A and C, then I have to give logic 0 to B and D. When I give logic 1 to B and D, then I have to give logic 0 to A and C. So if you see here the rotor part, here we have shown 8 teeth like 1, 2, 3, 4, 5, 6, 7, 8. If you consider normal rotor, in it will have minimum 50 teeth. 50 teeth here for the in order to represent the working purpose, we have shown 8 teeth in the diagram. 8 teeth are shown. So now if you energize the coil A and C by giving logical 1, then this becomes assume this becomes north pole and this becomes south pole. Then this north of this teeth will get attracted towards this one and this south will get attracted towards this one, because this is north. So this south will get attracted towards this one. So this north will get attracted towards this one. So this one. That means it will make one rotation. After that you energize coil B and D. That time it will make one more rotation. Like that if you keep on energizing the coil, it will complete one full rotation. It will complete one full rotation. So this is the diagram, for explanation purpose we are using. Here you can see 4 poles are there, that is A, B, C, D, and here for explanation purpose only 2 teeth are shown in the rotor. This is the north and this is the south. So here 4 poles are there, that is, so this one is pole A, this one is pole C, and this one is pole B. This is A, this is B, this is C, and this one is D. Suppose if I energize this and this, this and this, now this becomes south, this becomes north. Think this becomes south and this becomes north. That time south and south and south, this south pole repel this teeth get repelled because of this same pole, and it will get attracted towards the north pole. So it will make one rotation. Now this teeth become horizontal. Once again, if you energize this and this, then it will make one more rotation. In that way, you need to energize the coil to make the complete rotation. Now we will see here there are different types of stepping of the stepper motor. First one is called as a full stepper, second one is a wave stepper, third one is a half stepper. In the full stepper, so first you need to energize coil A and coil B. So as I explained in the earlier diagram, when you energize coil A and coil B, that is, when you energize coil A, this one, coil A and coil B, this will get shifted by one step. Now in the second time you will energize coil B and coil C. Now this will get shifted by one more step. So in the third you will energize C and D. Next D and A. Like for full rotation it requires totally 4 steps here. 4 steps, full rotation like 360 degree rotation, it requires 4 steps. Suppose in order to achieve wave step, you no need to energize both coil. In this case, you need to energize only one coil at a time. For example, this coil, if you energize this coil, and if this becomes south, then it will repel from this one and it will move towards that side. Similarly, if you energize that coil once again, it will repel once again and move towards, makes one more step. If you once again energize this coil, it will make one more step. Like this, it will rotate. So we have one more classification, that is off step. In the off step, you first energize coil A, then you energize coil A and coil B. When you energize only one coil in the off step, this will not make one step, this will not make one step, this will make only off step. That is, this S will come and stay in between here, and this N will, like this, it will remain like this, like this. So it will not make full step. Full step means from ear to ear, it will make half step. So next, in the next iteration, in the next this one process, you need to energize coil A and coil B. That time it will make full step. Full step. That is, it will come to the it will complete full step. After that, you need to energize only one coil, coil B. Then it will make half step. Next, you need to energize once again coil B and coil C. Like this, it will continue. That's why here 8 iterations are there. In the other cases and all, 4 iterations are there. So these are the 3 types of stepping of the stepper motors. Now we need to understand like what is the angle it will cover in single step. So we will see here. So what is the angle it will cover, or what is the step angle? So that is calculated by the formula 360 divided by number of stator poles and number of rotor teeth. We know normally there will be 50 teeth. 50 teeth will be there, and number of stator poles, 4 poles will be there. So if you calculate 360 divided by 4 into 50, you will get 1.8 degree. That means to cover 180 degrees, to cover 180 degrees, you need to make 100 steps. So to cover 360 degrees, one complete rotation, you need to make 200 steps. Similarly, in wave step it is same, but in half step it is divided by 2. It comes like 0.9 degree, something like that. So now how you will connect stepper motor to microcontroller? You cannot directly connect stepper motor to microcontroller. There is a driver IC. So in order to connect the stepper motor, or interfacing IC circuit board is required in order to connect the motor into stepper motor into microcontroller. You can see this is the IC. The IC number is ULN 2803. So it is available from Texas Instruments and ST Microelectronics. This IC is used to interface stepper motor to the microcontroller. Stepper motor is connected to this IC, and 4 more pins on this IC is connected to the port pin of the microcontroller. Port pin of the microcontroller. With this, you can interface the stepper motor to microcontroller. So with this student, we have completed the stepper motor. The next thing is relay. We will see this one in the next session. Thank you. Hello student, welcome to the one more video session of microcontroller and embedded system. This is Vasant Naik from Canara Engineering College. In the last video, we studied different input and output device that can be connected to the embedded system. Other than that, we have studied the memory concept like RAM and ROM. So in this video, we are going to understand remaining output device like Piezo buzzer, push button switch, keyboard switch, keyboard pad, push button switch, piezo buzzer. All these things we will going to study. First we will see relay. Relay is also an electromechanical device. It can be used normally it is used in the embedded applications. For dynamic, it acts like a dynamic path selector. Why I am saying it acts like a dynamic path selector is it is used to change the path from one point to other point. That's why it is called the dynamic path selector for signals and powers. Okay, so the relays units contains relay coil made up of insulated wire on the metal core and metal armature with one or more contacts. So how it works? When voltage is applied to the relay coil, current flows through the coil, which in turn generates magnetic field. So the magnetic field attracts the armature core and moves the contact point. The movement of the contact point changes the power or signal flow path. This you will understand with more if I show you the diagram. So in the diagram here you can see the diagram. The first one is a single pole, single throw, normal open relay. Second one is single pole, single throw, normal closed relay. Single pole, double throw. In the first case, when you energize this relay, this will generate a magnetic field. So that magnetic field will move this contact from this point to this point. That means this will close the contact. It will close the circuit or it will close the contact. Normally it is open. When you energize this relay, it will close the contact. So if you de-energize this one, it will move away from this point. It will remain open. So in the second one, single pole, single throw, normally closed. Here already the contact is closed. When you energize this relay, then this will open. When you de-energize, once again it will close. The third one is like path selector. Here it acts like path selector. Here it is already connected to this point. When you energize this relay, it will move from this point to this point and it will close this path. It will close this path. So when you de-energize, it will move from here to here and it will close this path. So in single pole, single throw configuration has only one path for information flow. For normally open single path, for normally open single pole, single throw relay, the circuit is normally open and it becomes closed when the relay is energized. Normally closed single pole, single throw configuration, the circuit is normally closed and it becomes open when it is energized. Then in the other case, it is closed and already closed, and when you energize the relay, it will move from one contact to the other contact. So now how you can connect a relay. This is the circuit diagram. Here you can see the load circuit is connected through relay, and there is a relay driver circuit which connects to the port pin of the microcontroller. So when there is signal comes from the port pin, this relay will get energized and this will close this contact and it in turn close the circuit. So in this way relay is controlled using relay driver circuit. So next one is Piezo buzzer. So it is a output device. It is a piezoelectric device for generating audio indication. Piezo buzzer contains piezoelectric diaphragm which produce the audible sound. There are two types. One is self-driving and second one is external driving. In self-driving piezo buzzer, it generates only predefined tone, but in external driving piezo buzzer, it supports generation of different tones. So piezo buzzer can be directly connected to the processor or controller sometimes, but sometimes it needs some circuit diagram or driving circuit. that need to be connected in order to connect to the controller or microprocessor. But in generally it can be directly connected to the port pin of the microprocessor or a microcontroller. Now next one is push button switch. So push button switch, normally it is an input device. It is used for two configuration. One is to push to make, and other one is to push to break. Push to make means it will close the circuit, when push to break means it will open the circuit. So the push button stays in closed for push to make configuration, and it stays in open for push to break configuration. So it is used in many embedded applications, like push buttons are used for reset, start switch and pulse generator. So in the next diagram you will see actually how a push button is used for generating momentary pulse. Here you can see the circuit diagram for the corresponding this one. You can see here it will generate high pulse and low pulse. So in this diagram you can see like the push button switch is connected, and here at this point is connected to the port pin, and this is a low resistive path. When you push this switch, then anyway it is connected to the ground, so low signal moves to the port pin, So but in the other case here, push button switch is connected here, so when you, and this is the high resistive path that is connected to the ground, when you push this switch, then this will take this path rather than high resistive path. That means high pulse moves inside the port pin of the controller or processor. Here low pulse moves inside the port pin of the controller or a processor. So in this way push button switch works. So in the next session we will see the keyboard. Thank you.